The intense storm that hit Brockville on Canada Day evening, Wednesday, July 1, 2026, was a powerful reminder of how volatile summer weather can get when extreme heat meets an unstable atmosphere. Here is a detailed breakdown of the atmospheric science behind how this system was built and the resulting rainfall. Part 1: How the storm formed, the atmospheric engine. Thunderstorms require three fundamental components to develop: moisture, instability, and a lift mechanism, a trigger. The weather setup over eastern Ontario provided all three in extreme amounts. One, the fuel, high heat and oppressive humidity. For days leading up to the storm, a massive heat dome sat locked over the eastern United States. This high-pressure system acted like a pump, driving incredibly hot, tropical air northward straight into southern and eastern Ontario. Temperatures in the Brockville area soared between 31 degrees Celsius and 35 degrees Celsius, but the real issue was the water vapor in the air. High humidity pushed the humidex to a suffocating 40 to 45, providing an immense reservoir of latent energy, heat energy stored in water vapor. 2. The unstable air, instability. Because the air near the ground was heated intensely by the sun and loaded with moisture, it became much lighter and more buoyant than the cooler air high up in the atmosphere.
Here comes the rain.
This created a highly unstable environment. Think of it like a cork held underwater. The moment it gets released, it wants to rocket upward.
Oh my gosh.
3. The trigger, the northern edge fracture. Brockville was positioned right along the turbulent northern boundary of this heat dome. As a cold front and smaller atmospheric boundaries, like lake breezes from the Great Lakes, pushed into this volatile air mass, they acted as the trigger. The dense, cooler air forced the hot, muggy surface air to rise violently. For explosive convection and wind shear. As the moist air shot upward at high speeds, a process called violent convection. The water vapor condensed rapidly into massive cumulonimbus, thunderstorm, clouds. Strong winds at higher altitudes, wind shear, helped organize these individual storms into a fast-moving, severe linear complex or squall line. This line slammed through the region with frequent, intense cloud-to-ground lightning and wind gusts reaching up to 100 kilometers per hour, which snapped trees and power poles across Brockville. Part 2: Rainfall totals. Because the atmosphere was so thick with moisture, the precipitation efficiency of these clouds was incredibly high, resulting in torrential downpours. Brockville and Leeds-Grenville, the storm cells trained over the area, meaning multiple heavy downpours moved over the exact same tracks one after another. Brockville and the immediate Prescott to Gananoque corridor swallowed a quick 40 millimeters to over 60 millimeters of rain. This rapid influx of water caused immediate localized street flooding and overwhelmed drainage systems. The regional record, Ottawa Valley. To put the sheer moisture capacity of this system into perspective, the core of the heaviest moisture alignment set up just an hour north. The Ottawa airport was completely inundated by 111 millimeters of rain on Canada Day, shattering its all-time single-day July rainfall record.
You think it's going through now? Maybe a tornado soon or what? Looks like it. Shit. Oh my gosh. This is bad now. Uh-oh. Wow. Oh my gosh. I think I better get out of here. Whoa. I'm soaked. Wow. Well, now I got a warning saying severe right now. So it must be going through then. It says Rockville severe. Warning. Alright, I'm going inside.